Good afternoon, colleagues. Good to see you. It's always a pleasure to meet also some of the former PhD students. Fabricio was not my own PhD student, but I was as a professor in his committee at the time, and we talked about it over coffee just earlier today. And it was an exciting time when Fabricio was there in Delft. There was really a lot of catchment hydrology happening, and the group at TU Delft, IHE Delft, and Deltaris and other players were really, it was very innovative, I feel, at that time, some 10, 15 years, no, probably 15 years ago. Good. I hope I can fulfill what he said, that he said, I know how to make impact on policy making. I do my best, but I think, sometimes you receive these emails, oh, you still have to send me the title and the abstract of your presentation. And I came up with a title, which is somewhat general, I believe, so supporting operational management. So therefore, I put in, don't read all the text, but putting in first a short explanation. What do we actually mean by operational hydrology? And that is really where we work on as the World Meteorological Organization. We supporting our members. So these are the operational hydrological services in the different countries. And it's really about real-time measurements, but not only the measurements and observation, but also the collection, processing, archiving of data, and then distributing that, doing hydrological modeling, generating some services out of that, making predictions, and forecasts and warnings. So it's along that whole value chain. So that's what we understand by operational hydrology. Short explanation. And the overall objective is to support decision making when it comes to water. Yeah, that reads capacity building, but also science and technology. And more science is really necessary. So we in Delft, sorry, in Geneva, we're not. It's not a scientific organization. No, it's more kind of it's a UN. It's a part of the UN, and we are supporting the National Hydromet Services, as I said before. But it needs science and innovation throughout the chain, from the better observation, from the better data sharing, from better metadata standardization of that, but up to innovative systems for making actually data accessible and usable. There's a lot of data out there which we usually don't use in our models. So I was very pleased to hear that some of you work on AI models, which really help us to machine learning, or which really help us to get a better handle of the amount of data that is there, but in hydrology often is not fully used. Yeah, Fabrizio said that I'm originally from Freiburg. Somebody just asked me. I did my PhD there in the 90s and then became professor in Amsterdam and Delft, and then was at IHE in the management for some years before I worked more for water and development organizations in Asia and Africa. And also most of my work, while I did my PhD in the Black Forest Mountains in Germany, I think most of my more recent work is all in Africa and Asia, and less in Latin America. Good. Fabricio said I wanted to talk about policy, and originally this talk was planned when I just came back from the COP, from the Conference of Parties for Climate Change, and I prepared the PowerPoint, but I came back with some sort of infection, and I was really down, and we had to cancel that talk. But when I prepared it, I thought I really want to share two experiences. One is the big UN water conference which we had last year, and the other one is the COP, and I'm not sure if you have been at the UN headquarters in New York before, and I've been there a few times and spoke. I usually was in the basement or in -1 in one of the small rooms, and talking to a handful of other people about the importance of water. This was different. The whole UN building was full of water talks for 3 days, nothing else in water. In the General Assembly Hall, you see the picture there. Everybody talked about water management and the importance of water in policy making, and it was first time after 46 years that such a happening was really happening. Was amazing, and in all these small rooms where I usually spoke, and it's kind of negligible, everywhere was side events, and everything was talking about strengthening policy and decision making through water management. So it was really an exciting conference. Some more than 2,000 participants were there, 11 heads of state, and 120 ministers, and 160 plus member states made statements, and so it was really exciting from a water policy point of view. Yeah, and what is it was exciting to be there and be part of that discussion, but it's also interesting. What are the main outcomes? And I want to speak a little bit about that. There was no negotiated outcome document. This from the beginning was considered too difficult, because water, particularly in transboundary cases, often is kind of very political, very difficult countries don't agree on data sharing, etc. So it's very, very tricky to get into transboundary discussions, and therefore they never even attempted to come up with a negotiated outcome document. The main outcome was a water action agenda where some 700 plus actions were submitted. We submitted 3. Maybe Eawag also had a few. I didn't check. I should have. But this was more kind of people kind of registered. Sometimes what they do anyway, and but it kind of demonstrate the commitment through these actions. But that was the main outcome, and a lot of interactions and discussions. So I don't want to downplay it, but it is interesting compared to other conferences that water is considered too difficult to have a general outcome document. One of the most interesting things which I found, and I'm sure a lot has been said, there's hundreds of side, at least more than 100 side events probably, and I'm sure I'm not attempting to give an overview, but I found one study from the Water Policy Group quite interesting. They were asking, before the conference started, they were writing to all the water ministers of the world, to all 193 countries, and say, hey, what do you consider as the main challenges in your country to solve water? Yeah, and I show a couple of slides, and it's all coming from the Water Policy Group, and I found that quite interesting. And the first question is, what is the greatest risk for achieving water outcomes? Maybe not a big surprise, but climate change was considered number 1. Yeah, and these are the water ministers were asked. I'm not sure if all the water ministers themselves filled in the questionnaire, but probably they had somebody. But still, you know, it is the water ministers of the country. It's the representative voice, and more than 90 responded to that. Interesting is also, it was not only the Western countries or the more developed countries, it was a good geographic representation. It was a good representation with high income and low income countries. So it's kind of more or less representative. So not bad. And they said climate change is number 1. Floods and droughts and increasing water demand is really scoring much higher than all the other challenges. Second question, you know, what is for you the greatest challenge to maintaining good water management in your country? And the majority said it's infrastructure. I don't think that this is the main problem in Switzerland, but in majority of the countries, infrastructure was considered number 1. But also things like information, institutions, regulations, etc. These are main challenges for the water ministers. But inadequate data and information was scoring number 1, including infrastructure. So it could be physical infrastructure as well as data infrastructure, obviously. Then multilateral process. So I'm working for the UN now, and it's interesting. So what would help you as a water minister the best? What should the UN and the multilateral processes deliver, you know, to really support your work? And it's interesting. Number 1, and it's beautiful. I hope you can read the handwriting. It talks about scientific information, including data collection and analysis. And so beautiful. I was used to that. We always get, no, water problems it's all about governance. It's very complicated. It's about better regulations and transboundary agreements and institutional setups. No, the water minister said number 1, it's scientific information and data. You know, this was an eye opener to me. I didn't expect that at all. Number 2 is then water across sectors, and sharing best practices, the type of work that the UN usually do. So we try to facilitate data collection, we try to share best practices and guidelines and that type of work. And that was considered, they want us to do this. So I found that really interesting. And for you, if I may, as many researchers, what is from the multilateral processes for science? Probably many of you are involved in international science initiatives. What helps you the most? And it's the overwhelming majority said it's also information about data at the global and regional scale. That's what they expect from science efforts. Huh? So yeah, I found that quite. So I think Eawag is in many ways doing the right thing, because I think you're very, very contributing to this. Finally, and it's the multilateral process for science and data. What kind of data would really help you, water ministers? And they said, we need better water data and information at country scale, better projections, better models, things like Fabrizio and colleagues are doing. So better predictions, how will the system behave under different land use, different climate, etc. Better monitoring and evaluations, assessments of the resources, not just columns of data, but really what does that mean in a bigger context? So I found it quite interesting that this is what the minister said. And it's always good to listen to them and then respond in our field. Good. This were just a couple of slides to kick it off, just to say, well, it's good to listen to the demand side of our science, and the water ministers are one part of them. The main outcome, there were 9 main points mentioned by the final statement by Antonio Guterres and the President of the General Assembly, and I don't want to go through all the text, but today I will try to address 3 main points, and that's a more integrated water and climate policy agenda, something we are working on, but also more data, make it more available through operational global water information systems, and also early warnings, better warnings for water-related disasters. And there's a couple of others which were also considered as the key outcomes, and obviously I'm happy to share the PowerPoint if you want to go into more details. This was the water conference, and a bit shorter now on the COP. When I prepared this part of the presentation, I literally was flying back from the COP, and I'm not sure if some of you were there. It's kind of crazy. It's more than 90,000 people were there. It's kind of talking about climate change, flying all the way to Dubai, all of us, and okay. And but it was interesting interactions as well. So I did get, probably doing my Christmas dinners and everywhere, the question, why do your scientists all need to fly to Dubai and discuss about climate change? And you know, there's trade-offs and difficult discussions, but I personally still believe that big meetings are necessary to advance the agenda, to advance policy making, to advance controversial discussions about a number of points. I'm coming to them now. Yeah, that it is more than 90,000 people, and there's more than 1,000 side events. I'm not so sure if that is really necessary. I'm not sure, but I'm not the one to judge that. Main outcomes include the loss and damage fund was established. That is great. More than 80 billion. That number might have changed recently. I'm not sure if that is the latest, but more than 80 billion were, when I'm on the plane back, were committed. But usually commitments are done during the days because the countries want to share with the others that they actually committed some billions. 80 billion is a lot of money, but it's nowhere if you really want to stay with 1.5 temperature degree. So it's a big number, but the needs are in the hundreds of billions, if not trillions. So it's kind of it's not that the climate financing problem is solved. It's the Einstieg in den Ausstieg. In German newspapers was a lot to get out of the fossil fuel economies, and a global stock take on where are we with respect to the Paris Agreement, and the global adaptation goal was adopted. Quickly on the global stock take, a lot more could be said than I spent time on this today, but I found it interesting that it was concluded that we should triple the renewable energy globally. We should accelerate towards net zero emissions, and that all makes a lot of sense. But tripling renewable energy, and that's probably needed, because if you look at the total greenhouse gas emissions, it's largely from the energy. Some 20% or so come from agriculture and forestry. I know there's other numbers where also agriculture and forestry up to 30% if you include all the pumping for the groundwater and for irrigation. But it's largely about changing the energy system if we want to reduce our carbon. So therefore, tripling the renewable energy is the right thing to do. However, this needs a lot of water. You know? If we scale bioenergy, biofuel, for instance, this requires enormous amount of land and water, which is maybe not necessarily there. Also, renewables often are what is water hydropower anyhow. That's special because often not consumptive to use. But if you look at wind and solar, it's relatively low in the direct water use. So there's a water footprint to it, but relatively low. However, there's huge fluctuations for wind and solar. So that is the challenge, that the sun is not shining equally all the time, and also the wind is not blowing equally. So storage of energy is the big challenge. And storage needs a lot of water. We are currently, Fabrice, you have to invite me later again, but because in March I hope to have the results where we try to assess what is the global water footprint of that change. And the first numbers really show it's dramatic. It's probably a third more water consumption, which we have already, and this water is probably not there anyhow. But don't quote me on the third. The study is still ongoing. It's done by the University Alliance for Climate Change, led by University of New South Wales in Australia. They are doing this as we speak. And we have hopefully some more robust data later in March. But it's certainly an enormous amount. Why is that? Because to the renewable energy fluctuations, to average them out, we need to store energy. One is pump storage. If you have the topography of Switzerland, that's possible, but it still has an impact on the environment. But also there's huge investments in pump storage at the moment in Australia, even in the UK. Billions, many millions are really invested because of evening out the energy fluctuations. And the other is batteries. Batteries also needs the mining of the elements that we need for batteries really requires enormous amounts of water as well. So therefore, the water footprint of renewable is not zero. Even if we think, oh, well, the wind and the solar doesn't need much water, you have to think it through, the whole chain. And then water footprint is significant. Again, the latest numbers we hope to share with you in a couple of weeks from now. The global goal on adaptation was also concluded at the COP. And adaptation to climate change has a lot to do with the changes in hydrological extremes. That in many parts of the world, we see that floods and droughts are more frequent or more severe and change in their probabilistic distribution. So that if we need to adapt to this new climate, it has to do with managing of extremes. Therefore, just copy it. Don't read all the text in yellow. I put some highlights from that goal as the way it was concluded. It's number one is mentioned water. It's really about reducing the climate-induced water scarcity, water-related hazards, so floods and droughts, water supply, climate resilient sanitation. I know that here in this organization you work a lot on this field. So these are all this were considered was mentioned first in the global goal for adaptation. So I think the COP led to something for our water field because there's an increasing realization how central water is to that whole agenda. Yeah. This was roughly on the kind of water conference and the COP. And I thought of moving on now and showing some recent data on climate change, what we compile at the World Meteorological Organization, and then I go more to in hydrology, what we concretely do. Then it's 8 o'clock and then I finish now. Let's see. Good. Some recent information on climate change. I think what many UN agencies is doing is compiling data, make it accessible, available to policy and decision makers for the field of weather, climate and water. The WMO has the mandate to do that. And I borrow here now a couple of slides from my colleagues working in the climate services sector, particularly, and they compiled annually the State of the Climate report. The next one comes out on World Met Day in March, 23rd of March, and the provisional State of Climate report from last year also. So I borrowed a couple of graphs, and well, I'm afraid that I'm sure most of you are well aware of the changes, the challenges related to climate change, and you have seen these type of figures repeatedly. But it is also important to continuously measure and publish them to keep the pressure on. Is while we are talking about the Einstieg in den Ausstieg, so the entry to the access to renewable energies, we don't see that in our records yet. And so if you look at carbon dioxide, methane, or NOx. It's constantly increasing, and also the lower figures always show the growth rate or the gradient, and they're all positive. So we don't see that turnaround in the atmospheric chemistry. Temperature, this is from the decadal report. We always 10 years. It's more robust if you look at a single year, but if you look at the decades, and depending on which temperature record you take, we see continuously increases of temperature. In the last decade, no surprise, was the warmest. Also, if you look at the annual temperature, again, there's different temperature records around the world. We compile them, compare them, and bring them together. And last year was again the warmest year on record, has been widely in the media. And probably the temperature was about 1.45 above the pre-industrial period, which is the reference period from 1850 to 1890. So we are kind of getting into 1.5. It's difficult to say when we actually exceed 1.5. So is it exceeding 1 year? Is it an overshoot, or is it on average? So therefore, these kind of decadal reports or longer average reports are important. But if you want to stay below 1.5, it's high time to really do something about the problem. Last year was also interesting because at the first half of the year, it was still La Nina situation, the El Nino Southern Oscillation system in the Pacific. And La Nina usually is a bit cooler for the Earth. And only from the second half, it was a La Nina situation, which usually is correlated to higher warming. So the second half of the year, I think on the 4th of July, not Independence Day of the US, but the 4th of July was actually the day when the La Nina situation was officially declared in a press conference in Geneva from our colleagues. And that second half of the year contributed so much to the warming that even we had La Nina for half of the year, it was still the warmest year. And the latest temperature records, my colleagues tell me, also January, February continued to be very warm, and very likely 2024 will continue to be very, very warm. Yeah, of course, we don't have a crystal ball to predict it, but it would be surprising if 24 would not be yet another record-breaking year. Let's see how the year develop. So, but no reason to relax. The same as you've seen all these figures. This is sea level rise, and you see a more rapid sea level rise over the last 20-ish years or so, even with a stronger gradient. So with no turnaround at all. So no time to relax. And the melting of glaciers, and particularly the last 2 summers, where some 10% of the glacier ice mass was lost in Switzerland. I think that was widely in the news from the colleagues in Zurich. And globally, we see the same pattern. Due to the warming, we see a diminishing of glacier ice. Sea ice is yet another parameter. Look at the last years and then look at 2023. Yeah? And colleagues tell us that even in the early months from 2024, it continues to be. I really feel it's going much more rapid than we ever thought. So I think the climate change is really it goes faster than even I expected. I'm not sure what your expertise tells you there, but I was amazed. Was it 2 weeks ago? We went also looked at some of the data from the latest data, and it's exciting from a scientific point of view, but frustrating when you think about it. It really goes very, very fast. What is the problem in hydrology? All these kind of beautiful figures are nice, but the challenge now, turn it back to hydrology, is the change when our challenge is to observe the system. We have declining observation networks worldwide, either if we look at surface observations for climate stations, but also for streamflow networks. We see declining networks worldwide. If you look at the lower figure, the blue dots indicate long records for many years and still continuous, while the more red or the orange and so always indicate record broken after so many years and shorter records, and maintenance is a big issue. So we have less and less ground measurements available. Same as if you look in particular to the developing countries, when you look at the hydromet observations, about roughly 80% are in a poor or declining state or inadequate somehow. 80% of all the networks in the developing countries, can you imagine? Huh? And in the developing countries, again, if you look at the hydrological data, roughly 2/3 or so of the data systems are poor or inadequate. So it really needs much more investments if we want to understand water resources dynamics. We need better ways to observe the Earth systems when it comes to hydrology. That's for sure. This was roughly on the climate change, and in the last part of my presentation today, I would like to move on and give a little bit of an overview of what we are doing in Geneva, and more than happy to, in the discussion, also to answer questions if you want to connect to some of these activities, if you find that interesting or contribute or use some of this, we would be delighted. Some 4 years ago, there was a WMO Congress, so when all the members of WMO from all the countries of the world sit together and make the big resolutions every 4 years, there was the hydrology action plan was concluded, and also the 8 long-term ambitions were concluded. And they say no one is surprised by a flood and everyone is prepared for a drought. So this is related to hydrological extremes. The third one is on food security. Floods and droughts, I believe, are the big part of our work. Food security we also support, but there's other UN agencies like FAO or the World Food Programme or IFAD work a lot on food security agenda, but we contribute with our data as much as we can. 4 and 5 are science related with high quality data, which we try to facilitate, and supporting science also in operational hydrology. Number 6 is a bigger one again, where I'll show a couple of slides in a minute. which relates to our understanding of water resources, and 7 and 8 are related to the sustainable development and water quality. Yeah, and water quality. I know that this is cutting edge here at Eawag. I do understand that, and it's not that we are doing water quality research. So and probably no institution in the world does it at the level that you're doing it. But so it's kind of supporting countries to better understand water quality data and measurements and monitoring and also assessments. That's the field we are working on. What we do there is one is we're doing projects. I come to that in a second, and the other part is we're doing normative work. So we are supporting members with regulatory material that we develop guidelines, how to measure stream flow, how to make seasonal predictions, how to assess a flood forecasting system, etc., etc. So there's different manuals and guidelines and technical regulations that we issue, and to support our members to do a better job, yeah, or do a standardized job. We all know if we all measure data somehow and it's not comparable and the metadata is not properly recorded, then data easily becomes very tricky. Huh? So therefore, there's a lot of regulatory, normative work done to support members. A lot of these guidelines need updating, and if you want to engage in that, that would really help us, because we need to make sure that the latest science is incorporated in these guidelines. And the interesting part is, when I was a researcher, we always said to, as a researcher, if you want to get a good performance from your director, it's about how many papers you write, isn't it? At the time, at least when I was in that business, it's how many projects you bring in and so on, how many students you supervise, but also how much you support society, isn't it? And that is usually a lot of hand-waving type of explanations, and it's more difficult. But contributing to these international regulations can be quite powerful, because if something is on international regulations, the member state's supposed to make that part of their national law. So you really influence policy setting in the country. So through these, not through a general guideline, but through technical regulation that can really be quite powerful to translate your science, your understanding into the operations in the country. So therefore, I encourage always researchers helping us to update it, helping us to bring the latest knowledge and science into these guidelines. It's two examples from more recent publications on seasonal predictions and flood forecasting that were published a couple of months ago. Yeah. But if you feel this is interesting, come see our website or contact us, and we're happy to. There's a process to engage, but we can discuss that in the discussion. But in general, I'm eager to bring in more science. Finally, just a couple of examples. I said that we are working a lot on floods and droughts, and that is based on the global initiative that's currently ongoing. You might have heard of that, the Early Warning for All. Antonio Guterres, 2 years from now, 2 years ago, almost 2 years ago, on World Met Day, he gave this speech and said, in 5 years from now, everyone around the world should be covered by an early warning system. Yeah, and everyone. And the first analysis when it comes to hydrometeorological disaster was that roughly half of the countries only have a multi-hazard early warning system. Huh? And the other half need to be protected. And also, if you have it, everyone in the country should be protected, including the poor and the marginalized members of society. So it is it's a major challenge he gave us, what in 5 years we should achieve. He then invited WMO to develop a plan for this, to implement that, and together with UNDRR and many other organizations, there's a Early Warning for All initiative that is globally ongoing, and we are supporting as much as we can. And a significant part of the disasters are water related. Yeah, I always stress that at the Meteorological Institute of Meteorological Organization in Geneva. We have many meteorologists, fantastic colleagues, but we shouldn't forget that also hydrology is actually an important part of it. Yeah, I understand me right, but I always have to keep up that actually some almost 80% or so of the disasters are water related, often triggered by meteorological events, but the impact on society is often the too much or too little water. Yeah? So it's the downstream effect of a tropical cyclone that makes the direct impact to society. Not saying that tropical cyclones are not important, but it's along the chain of the whole event we have to assess and predict. And early warning can be very, very efficient to save lives and properties. You know, there's one figure I often like to show to students, and they say early warning, yeah, well, interesting, but there's so many other ways what we should do. And I found that there was an interesting study, I think 2019 or so, it came out from the global, what's it called, the global adaptation. It's in Rotterdam. I forgot the exact name of it. It's the agency. It comes from the World Bank a bit. Global GCA. I forgot the acronym, but it's for adaptation. And they analyzed how do we adapt to different climate and what is most cost effective. And they looked at you can make your water resources management more resilient. Yeah, so different water storage, for instance, or protecting mangroves and tropical forests for coastal protection and coastal erosion, or improving infrastructure or making crops more resilient to drought or more resistant to salty water for irrigation. So they compared that, and then they did a cost-benefit analysis. So every dollar you put in that, how much does it pay back for society? There might be a couple of economists in the room, and I apologize already. I do understand this is difficult, and it's not that every dollar we know pays back with 5. So, but overall, all these studies, what they compiled was there's a cost-benefit ratio in the order of 4 to 5. That means every dollar you invest in protecting the mangroves or having better dryland agriculture really pays back to society with factor 4 or 5. So it's a good investment. Yeah. So keep on telling your pension fund and your development cooperation ministry and whatever. So it's a safe investment to invest in that. It's a good investment for society. But there was one measure which was really outstanding in terms of cost-benefit analysis, and that's early warning system. So every dollar put into an early warning system pays back on average with the factor 9, and you find case studies that's even up to 11 or 12. So it's kind of it's very effective in terms of return on investment. Yeah, that there's uncertainty in these numbers for sure, but the overall tendency is clear. So therefore, also Guterres and others were advocating strongly for this better early warning systems. What do we do in that respect? No one is surprised by a flood, so we do a couple of projects. We do the kind of guidelines and regulations and stat work, but also we do concrete projects where we help countries. Just a few examples. The flash flood guidance system is together with NOAA, the Meteo Swiss of the US, financed by USAID and other partners, including HRC in particular. It's supporting more than 70 countries around the world with better flash flood guidance. We are now scaling a program to early warning systems for floods, particularly in SIDS. You see the pinkish and yeah, the study, the countries are indicated there. It's particular for small island states where we want to support better flash floods. East Africa, water at the heart of climate action, financed by the Netherlands. We are doing a program. And in the Volta Basin from the Adaptation Fund, we also have an integrated flood. And now we have it, so we facilitate that countries have it. It's not that we in Geneva run models. No. It's really always our job is to strengthen the capacity in the countries to run integrated flood and drought programs. This was roughly on what we're doing in the field of flood management. And my final example, a bit more on the water resources side of things. When should I stop, Fabrice? It's always difficult with me to get me stopping.
15 minutes, another 10 minutes, and then
10. Good. Okay, good.
15 minutes of discussion.
Yeah.
Or maybe.
I have, because of our coffee break discussion today about the different scales, I think I stressed the importance of water data, how important that is. And if you look at the vertical hydrological fluxes that are happening at the square meter scale, it's mainly infiltration and it's plant water uptake and groundwater recharge, but it's mainly a vertical hydrology. Might wanna say. Christian Stamm is not in the room anymore, but I always quoted his PhD work from the 90s when I was lecturing on Wadezone hydrology. But it's largely about soil physics, and if we want to save water, it's about plant breeding or biotechnology and kind of looking at the kind of soil plant interaction. If we go on in scale and we go to the farm scale, to the hectare scale or to the farm scale, the lateral redistribution of water becomes much more important. So all the hill slope hydrology becomes more important, and other processes kick in. Huh? And if we move on in scale to an irrigation system where we redistribute the water artificially to bring it to the plants, that has, of course, major implications on the river system itself. And if we move on to catchment scale or even regional or global scale, a completely other processes come in. While the main disciplines maybe is on the square meter scale, it's about plant physiology and soil science and ecology, etc. While if we move on, then hydrology becomes more important, water management becomes important. While we look at the regional scale, it's more the subsidies to certain crops. Do we subsidize rice production in parts of the Mekong or not? Because that has much more impact on the regional scale water distribution. And also other players come in. While the farmer maybe defines largely, with the atmosphere, of course, then the farmer takes a decision about which crops, which field techniques, and so on. When if you move on in scales, it's kind of food security programs, national trade between countries, which crops do we present, which and where. So complete new stakeholders and decision makers come into the place to impact a water management decision. And we need the whole continuum of it. So it's great to do all the hill slope hydrology, but if we don't move on and also consider decision and processes at larger scale, we are unable to properly inform decision making and contribute to sustainability of water. One thing we are working on is a program that actually my colleague Sulagna, who's came with me today, is coordinating with many others. It's on HydroSOS. It's a hydrological status and outlook system. In a nutshell, we try to assess what is the current situation of the hydrology in a basin, in a country, or the world eventually now, and we update that. And what are the seasonal to sub-seasonal predictions? So we assess the current status, and then we make a prediction of how does it look like in the coming weeks to months. It's integrating all the data which we can get our hands on, ground-based observation, remote sensing, weather forecasts, etc., in some sort of hydrological model. But this is not a model. It's a framework how to assess that. And we're doing this in a number of countries. And then we have a standardized way to assess it and inform the countries that they have a good assessment of what's the current status of a hydrological system. And the advantage of that is that we have a globally consistent assessment of water resources. That's the main advantage of that system. And I believe some of the work that colleagues are doing might help us to do that even better. I think I skipped this, lack of time. To assess the hydrological system, it's very simple. I almost have to apologize in front of some of the hydrologists here. We define 5 parameters, how to assess them. These are snow water equivalent, soil moisture, stream flow, runoff from the fields, and groundwater. Keep it simple, and have a standardized way of assessing. For instance, we have for the stream flow, there's a couple of agreed characteristics how to characterize stream flow dynamics. Yeah, stream flow signatures we used to call them, and others, but we keep it very simple. Mind you, this is not about science. It's more kind of a simple, consistent way to assess water resources, to give policy and decision makers an assessment that they can understand, that they can quickly calculate, that is available on minimum data. We're not working only in Switzerland, so we work a lot in Africa and Asia where data dynamics are difficult, to have a standardized ways to assess that and make that comparable. Also, to show a couple of a lot of the thinking comes from the colleagues from the UK Centre of Ecology and Hydrology, UKCEH. They do this already in UK anyhow. What you see here is a color coding of a very dry situation in the summer 1.5 years ago or so. And you see the black line is the stream flow. And if you look at the lower graph, you see a seasonality and it's color coded. Blue is wet and red is dry. And you see the black line. So it gives it's low stream flow, but you can see from a probability point of view, it's even exceeding the 99% percentile. So it's really super dry. Yeah, and of course hydrologists they need the other way to characterize it, but for water managers and to characterize soil moisture and other variables, this is a simple way to characterize the stream flow dynamics. In the upper part, it was also very dry, but it's yeah, not so super dry. It's still in the reddish color, and obviously all these characteristics are per parameter per gauging station different. And if you do that for all the parameters, you have a standardized way to color code to assess the current situation, and if you then do seasonal to sub-seasonal predictions, you have a standardized way to assess water resources in the coming weeks. We are currently busy with working in this applying this hydro SOS in a number of countries, more than 60 worldwide. You see, it's all sorts of different stages. Few countries have something up and running, very few. Others are in different stages of getting started and developing that. And our aim is to have like just a consistent way of assessing hydrological dynamics. And if you help us to come up with better parameters or more data to assess it differently, we are delighted to further develop this. This is just a framework to do this, but it gets a lot of traction. Our last Congress last May, it was decided to do this globally. All the countries have, all the regions have their regional implementation plans, and it's really taking up as we speak. So it's really get a lot of traction. And finally, just a few slides, and then I close in a few minutes very soon, is the Global State of Water Resources Report. It's a report that we started to publish, the first one for 2022, 2021. Now 2022, we are now compiling the one for 23. It's like a hydrological yearbook where we bring together all the water information as good as we can about the status of the global hydrology and have a quantitative assessment of the status of the water cycle. You know, with some, I don't want to say envy, but with kind of impression, being impressed by in climate, how good they characterize the climate system globally. In hydrology, we find that more difficult. And we believe producing this global state of water report is a step towards characterizing the hydrological system continuously. Big thank you to all our partners to contribute that. Eawag logo is not there yet, but maybe you want to join us in the future. A few results. Whenever we use measurements. Yeah, this is for stream flow, but in many countries of the world, we don't get the stream flow in time, or it's not available. The rating curve is not updated, or there's issues. And then we use an ensemble of global models. So we have some 10 or so operational global hydrological models from Germany, Sweden, Netherlands, Japan, etc., US, NASA, of course, and bring that together in an ensemble prediction. When the models agree, we have an assessment way of color coding the water resources situation worldwide. You see a global map, and you see 2022, many parts of the world was very dry. Also, I talked about La Nina before, huh? And it was a La Nina year, and you see that particularly in South America and the extremely wet situation in southwest of Australia. This is typical for that type of climatological situation, that you have these patterns. Stream flow, whenever we had, you see the stream flow gauges that were available last year. And the good thing is, when we published the first record, we had, only a six or so stream flow gauges available. Publishing reports, people find that interesting. One also want to contribute to that. So we have more access to data. So people are sharing more data. So kind of being part of that movement to produce this report from the countries, you get more data in, which is fantastic. And we hope in now doing the one from last year to get even more access to data and make it more measurements based as much as we can. But we will always need hydrological models to do this, because we will never have all the gauging elsewhere. And you see only one station in Africa. Of course, there's more stations in Africa, but it was not accessible at the time to us. Huh? And is there no station in Switzerland? Is that true? My goodness. I know you have many, but somehow we didn't get there so yet. And so we're working on that. And look at the River Po, Fabricio, huh? He's from Italy. And it was at a record dry. The green line is the 2022 discharge, and was at the Lago di Garda, when you could walk to the middle of the almost not to the middle, but you could access islands before you could walk there, because the water levels were so on a record low. This is the inflow to reservoir, average out of 3 models. I found also that's also an interesting from a water management point of view. How much flows into our reservoirs is very important because I think water storage is one of the biggest challenges that we have. We did this paper some years ago where we tried to assess why society needs water storage. Yeah? One is for flood defense or environmental storage, but also for energy production, for water supply, etc. And already now we have a storage gap. We need to develop more storage. But very likely because of the climate change, increasing variability, more biofuels, etc., we need even more storage. And then we have more sedimentation to existing storage. And so we need really investment in storage is absolutely necessary. And I speak about the whole breadth of water storage, not only dams and reservoirs, but also nature-based solutions to store water. That is really one of the critical things which hampers sustainability. Good. I think in the light of time, I'm getting a little bit over time. I skip some other details of this report, and I would like to thank you for your attention. I think I was speaking a little bit too long, which is a bad habit, and I am looking forward to the discussion. Thank you so much.